Hello, everybody. In this Play 700 application note, I wanted to share what you can do with the CM-50, but this time with Android programming. So the topics are something called an OLLOBOT, and what it looks like here. And the OLLOBOT SDK. The OLLOBOT SDK will release sometime about summer 2016. And if it is in this application, I would like to apply this OLLOBOT SDK to the little CM-50 little carbot down here. So the OLLOBOT SDK is available on GitHub. You can go to the website, you can download it, and then it's an Eclipse project, so you can import into Android Studio and answering a few standard prompts, and then you can get it in, and you can make a APK file out of it. You can put it like on an Android phone, and then the app plays. So this is what the app looks like. You can turn LED on and off, LED status. And the nice thing about it, it will show all the dynamics of 2.0 packets that you send away and that you receive. So this is very nice. And then you may already quit and say, oh no, I have to prepare all these little packets, all these crazy FFD. Luckily, no. They create the robotics folks have created methods, Java methods for us to use, so we don't have to worry about it. They have a little application here, a little remote controller, the usual forward, backward, right, left, stop. You also can give it a voice command, and it will go forward, left, backward, and stop also for you. Actually, not stop, just forward, left, backward, right for a little bit. Okay, so how do we do it? So if you go in there and look at the code to make the OLLOBOT go forward, actually you just prepare the packet and then with a method to send away. So the method they use for the OLLOBOT is to write a double word, a double word packet, and you pass in parameters such as the OLLOBOT ID, which you need to know, and then the address where the function for the motor speed for port 1 is, and then you send in the data, whatever data you have here. You can see here it's pretty much 512, pretty much half power. I get into the detail of what this number is about first, later. So first you need to look at the control table of the OLLOBOT because we need to find those addresses and those IDs. That's a key point. And if you go to this website, they list this control table. And I found out that there's an error on that one here. You see this register, this is the decimal equivalent to the address, really. Okay, so it's the same. They tell you the size, the byte of the parameter you can pass through in there. 137 here on table, actually 138. Okay, and I'm going to find out how I found out about that a little bit later. So as far as ID goes, you look at table, you can see that the ID is 200. Actually, all the controller in robotics, all the controller, it doesn't matter which one our label is ID 200. The motor speed, of course, you can pull out from here is 136, so we know it. Okay, and then this little constant here that needs to explain something to do. So this one here is obviously minus 512, so that means pretty much half speed clockwise. And then this one here, 512 positive, that means counterclockwise, but it got shifted by 16-bit. So basically, the minus 512 will go into the lower byte of the double word, therefore it will activate port 1, motor speed. This one got shifted by 16 bits, so actually it will go into the speed of the right wheel here. Okay? So that's how to make the OLLOBOT go forward. Okay, and I will show you a bit later how it works here. So that's the code they gave you already, and I check out and it works great. So I say, okay, how do I adapt this one for my little CM-50 little bot here? Okay, so but here, oh, I forgot. Remember I told you that I found an error here? If you check all the Java code that they gave you, there's some utility file. That's where this is the correct one because, it's using this to compile all the Java code. All right, so let's go back to here. How do I adapt to the CM-50? As you know, first you had to find a control table for the CM-50. And I found out that Robotics never published any control table for any of their controls, CM-50 or anything. I dig around, I found out it's Opera Scratch. Some of you may remember this is used with Scratch 2 interface, so that you can use Scratch 2 with the CM-50. If you install it, you dig down into this path. This is in program file x86 Robotics. You dig down all the way to here, 2.0. There's a bunch of XML files. And hey, it listed all the controller in there. And if you pull up the XML file for the CM-50, for example, you found out that, hey, the up-series motor, the gear motor there, it's also using address 136. It's not used in this particular demonstration, but let's say somehow you need to read the IR left, center, or right, you found out that these are the addresses. And actually, if you look at all the controller, you found that the robotics people are very methodical. Like 136 here, they're trying to keep the same port for all of their controller. So like OLLOBOT 136 for port 1. Well, for CM-50, 136 also. But sometimes they had to change it, but they tried to do it that way. So this is very interesting. Okay, so I found a control table, so I know that this code here, 136, 200, it will work for me. So I charging on. So remember, the OLLOBOT solution was you send one double word packet, and the OLLOBOT will go forward for you. First, I struggled with double word, find out, it didn't work. The CM-50 does not comprehend a double word. So it can have a word. So I had to send two packets. So one packet to port 1 motor speed, and then another packet of a word size only to motor 2 address, port 2 address. And remember, if it's 512 shifted by 16, it's supposed to go to port 2, so we have 512 here. And then minus 512 is supposed to go to port 1 motor speed, but you say, what is the big deal that 1024 plus 512? Why didn't you send minus 512? And I found out also another thing too, the OLLOBOT controller is very sophisticated. It understands negative numbers. Good old CM-50 does not understand negative numbers. But if you remember, the speed of any servo motor was, 0 to 1023. Remember that? 1023 maximum speed, 0 is stop. So, and then you remember maybe back in some of you going to do task programming. So 0 to 1023 is at 10-bit. The 11-bit, if you put a 1 there, that will make it go clockwise. If you don't have it, it goes clockwise. Or rather, the 11-bit here is the direction. So minus 512, meaning you have to have a 1 here. So that's why I had to add 512 to 1024. When you add to that, boom, that ring works. Okay? Before I do the demo here, let's go on. It's very interesting in practice. I found something. Remember, the CM-50 have 2 single word packets. And in practice, Bluetooth sometimes loses one of those packets. So even when you see, I don't know, we'll see in the demo a little bit later here, although I push and tell it to go forward, but sometimes I see the bot spin left or spin right. After a while, I figure out, it lost one of the 2 packets it sent out. So the other motor was never set to the proper one. So that was the problem. And remember, the OLLOBOT solution was send a double word. So practically port 1 and port 2 motor speed got set practically at the same time. So both motors are practically, well, maybe it's microsecond differences if you want to be precise, but most motors therefore are always in sync. You're going to see when I do the demo, the 2 motors go as all in sync, so go straight. And well, BT still could lose the packet, that the OLLOBOT packet. But if it loses, well, nobody knows the difference because the bot should continue whatever previous command was given to it, so we cannot tell the difference. Okay, so I'm going to stop here a little bit and get it set up, and I'm going to show you how those 2 bots behave. Okay, so I'm back. So this is what the apps look like. So right now it's set up, it hooked up to the OLLOBOT, and then I'm just going to make it go forward. Backward. So going backward, it drags a little bit. You can see because of the little ball in the back there, really. So turning left, stop. You see it stop. Pretty snappy. As soon as I push stop, it stopped. Pretty snappy. Okay. So I'm going to pause again, and I'm going to get set ready for the little CM-50 bot. Okay, here I'm back. So I haven't changed the interface, so it's just the same. But right now it's hooked up to the CM-50. But I'm gonna push forward. See, sometimes it's just only put on the right guy to receive the message. So I had to push forward again. Now it got both of them. Stop. At least stop is stopping it nice. Let me try backward. So I let backward. It's both motor got the packets at that time. Let's try forward again. So this time both packets got there. Backward again. So we're getting good now. You see, turn right. Stop. Turning left. Stop. Let's try backward again. So most of the time it ain't bad. They didn't lose any with the one pack. Both packets went up, but okay. You see, back. Good. Up. It just lost one. Stop. Forward. Up. It lost one packet. And then push forward again. Come on. Oh, here we go. Stop. Backwards. So both packets didn't get lost. Forward. So you see, most of the time, it won't lose. The both packets got okay. But that's how it goes. That's it.